So, hello, thank you so much for the invitation. I'm sorry for the delay, it's a little bit difficult to move the cursor backwards on the screen. Yeah, so today I'll be talking about not so much about PyTorch directly, but about a data set that hopefully some of you know that you can use with PyTorch. So, for those of you that don't know what Common Crawl is, so let's do a little introduction. So Common Crawl, it's a Common Crawl that we do. So Common Crawl is actually a foundation that has been doing a generalistic crawl for over 17 years. Now we have around 275 billion pages. And it has always been free. It has been cited in over 10,000 research papers, and we add data every single month. So we do a batch crawl every month. At some point during the pandemic, it was bi-monthly, but now we are back to one every single month. It was started in 2007 by Gilad Bass. So if you want to know more about him, he's the person that invented AdSense that is used today for running ads at Google. So Common Crawl is intended, or at the beginning it was intended for research and also search index, because in 2007 nobody was talking about LLMs yet. And now that we have LLMs today, it has become one of the, if not the main data set for pre-training LLMs. We have over 100 crawl released today, and that amounts to over 9 petabytes of data at the end of 2024. So if you want to download the data, it's free. It's available in the S3 bucket. We're part of, the S3 bucket called Common Crawl. We are part of the Open Data project, or program, sorry, from AWS. You can access it via AWS or via HTTPS from outside. We release the data in 3 different formats. So it's WARP, which are the actual HTML files that we crawl, the web files, which are the text extracts that we do, and the WAP files, which are the metadata and link information. That is very used for doing image datasets, for instance, or multimodal datasets, because on the WARP files, you will only find HTML. So if you want to get multimedia, you will have to get the WAP files and crawl the images or the multimedia content yourself. We preserve all the robot exclusion protocol data. So it's robots.txt, HTTP headers, and meta tags, which we hope our users follow when they are doing derivatives of Common Crawl. And then we generate a graph, a web graph each month that you can use. We have a client because people were complaining about it's difficult to download the data because we have too much traffic. So we have a client now that you can use to easily download the data. So how does it work? We have our own crawler that is based on Apache Notch. It's open source on our GitHub repository. It has the user agent CCBot. We run everything from US-IS1 in AWS. We always perform a seed crawl, so if you don't know how crawl works, first you do a seed crawl. So you have a starting URL list, and then from this URL list, you start following links, and you discover more content. So we always do a seed crawl. We do a ranking with the web graphs using this thing called harmonic centrality, and then we take samples of websites that we discover. We always request the robots.txt, and we always respect robots.txt. So this is probably one of the most important slides, because a lot of people right now want to go and do their own crawl. Trust me, crawling is not as easy as it seems. So we think that we crawl responsibly, because we respect, as I said, that the robots.txt data, we respond to takedown and legal requests. We crawl slowly, which is something that right now we see our colleagues at the AI companies are not doing that much. So what we are trying to tell people is don't try to do your own crawl, use our data instead and help us improve common crawl. We have years of experience. And we are also trying to work in preference signaling for AI. So this is a work that we're doing in collaboration with the ITF to extend robots.txt to actually let content creators and right holders express preferences about AI. So we consider ourselves probably the most responsible web crowd that is available for training data. So, okay, apart from that, like before all the AI stuff, Common Code was used for search indexes, socio-political research in linguistics, in economics, people doing marketing even, and even governments doing security research on what's happening on the web. So okay, so let's talk a little bit about this. This is very. I'm not going in depth, but like if you want to know more about this specifically, we can talk afterwards during the coffee break. But yeah, so how is it used in AI? So if you look back, it's kind of complicated. So before LLMs, you had like word embeddings, and for word embeddings, projects like Love and Fasttext use Common Crawl. But then something that people don't quite remember is that back in 2018, companies, and you can see the citations there, companies like Google and OpenAI were saying that you shouldn't use web data for training LLMs because the data was too noisy and it wouldn't generate good models. So if you look at the first, for instance, BERT model, it was using Wikipedia books, but then that changed. Probably the first two models, let's say big, also they're small today, but like let's say big models that train with Common Crawl data were actually Roberta by Meta, and Camembert, which I was part of, that was also by Meta and Inria here in France. So one of the things, actually on that Camembert project, one of the things that we found is that it's actually good to train with web data, mostly because it has very good coverage of like the registers, like the different registers and uses of the language. So the conclusion that some projects have is like it's good to have diverse data for pre-training LLMs. The only problem is that, well, it is not really 2024, but if you look at like big LLMs now, this is Llama. Sadly, not a lot of projects right now are reporting what data they use to pre-train. But there are other projects like Olmo or Dolma. Well, Olmo and the dataset use Dolma, that do report some. And you can see that most people are using around 80% web data to pre-train LLMs. So the problem with that is that what I always try to say about data in pre-training is that web should be the base, and it's a good base, but you need more. You need linguistically diverse content coming from books or literature, coming from scientific research, and coming from things like code, which are not necessarily that common on just random websites. So how do you process Common Crawl? Like here are some pipelines. You can take a photo if you want, but there are many, many more. And I wanted just to give like a skeleton of what you would do with Common Crawl data if you wanted to do your own preprocessing pipeline. Probably the idea is that if you don't have, because some people have lots and lots of compute, but if you don't have compute, what you want to do is first, try to optimize it as much as possible, and two, try to parallelize as much as possible. So here at the arrows, what I wanted to do is say things that you can parallelize. And if you don't have infinite resources, you will quickly get that you cannot parallelize everything. For instance, at the end, I put something called quality filters. So if you look at projects like FindWeb, they are now using educational filters. And these things are quite expensive. So these are things that you cannot parallelize. So the way that I organize it here is very important because you want to try to do first, since you are filtering, you want to try to do first the things that are cheaper to get rid of as much data as possible, and at the end you do the things that are most expensive so that you have to process as little data as possible at the end with the expensive tasks. Okay, maybe something about ranking, which is, I have seen one project using it, but not many projects use this. Well, at Common Crawl and in web search in particular, we do something called ranking of the URLs that we crawl. And at Common Crawl, we do both page rank that you might know and harmonic centrality that not many people know. And harmonic centrality is just like when you have a graph like this, it's just the mean inverse distance to all the other vertices. And then if you have an unreachable vertex, like its harmonic centrality is considered to be 0. And it's just a measure of how well connected or how important something is in a network. Here is the equation, is very simple. The thing that nobody uses about Common Crawl that I want to tell you, hey, why don't you use this, is that we have, for every single crawl, we publish a web graph, and in this web graph, we compute for you all of the rankings of the domain. So what I am telling people is that, hey, well, maybe not use it directly for filter, but you can use it at the end of the pipeline that I show you to try to rank the documents that you might want to make, like, that you might want to prioritize for that pre-training or for constructing whatever data set you want to do. Maybe one last thing that I like to talk about, because we are trying to engage with the community on this one, is that people think that, well, language cover is already good. One of the things that we are trying to do is work on language identification, because, well, everybody's using some flavor of fast text or CLD2, CLD3, and if you try to evaluate it on like very clean data like European Parliament or Wikipedia or whatever, it's actually very good. But as soon as you go to things that are more noisy, which are the things that we crawl, like Twitter, for instance, well, I mean, we don't crawl Twitter, but Twitter resembles things that we crawl like in forums. You can see that the performance of these very simple models drops quite like suddenly, okay? So we have two initiatives that we want to promote with the community. One is this Web Languages project, in which we do a seed crawl. So we don't have complete coverage of the web, but we want to improve that. And what we are asking people is that if you speak a language that is not well covered by Common Crawl, submit to us the languages the websites that you normally visit in your language, and then we will add it to our seed crawl and try to get more content for your language. And the second one is the Lang ID project, in which we show you snippets of Common Crawl, and they are pre-annotated, and you just select the spans and say like, okay, this is in my language or this is not in my language. And this is very important because this is a signal that we can use to actually get more content for those languages that are misrepresented, which we think is important because, okay, some people say maybe pre-training is dead, maybe we can just keep keep reusing the models. But I would say like, okay, for English, maybe, although one day there might be another architecture that you will have to pre-train. But for the other languages, we are nowhere near the coverage that we have for English. So we really need to do something to develop these technologies for those other languages. So anyway, that's it. Thank you.